Okay, good afternoon. So let us continue the lesson. So do you remember we talked about improper integrals? We started talking about the improper integrals, and I gave you definition for calculating the improper integrals. But so you have been used to this idea that sometimes we are not able to find a primitive function for the given function. But the question is that, is there any way that we can still know that the improper integral is convergent or not? So that is an important theorem, a comparison theorem for integrals, which we already actually know, yes? So this tells you that if I have so what page is it? Yes, so this is actually telling you that if you have two functions, so on an interval, so consider an open interval a and b, and what are these numbers? A is less than b, but b can be also positive infinity, and then a can also be negative infinity, okay? So this theorem also works for this case. And then on this interval, assume that you have two functions f and g so that they satisfy this condition. Yes? Then you know that this is true, that the integral from a to b f of x dx will be less than or equal to the integral from a to b gx dx. And this has a good consequence for us, yes? Because if the right-hand integral is convergent, it means that the answer to this is a finite number. And this is supposed to be smaller than that one, because I'm assuming that f of x is always positive on that interval. So this is also true. So this means that if this integral converges, this integral, which is supposed to be smaller than integral, will also converge, okay, even though we don't know its value, okay? And then, but if it diverges to infinity, we cannot conclude something about the convergence or divergence of this one, yes? Because if it is infinity, this is a smaller than infinity. It could be still infinitely large, or it can be actually a finite number. So be careful. If this one is a smaller than that one, and the bigger one is convergent, this will imply that the smaller one is also convergent. On the other hand, if the smaller one diverges to infinity, this bigger one has to also diverge to infinity. So these are the only things that you can use, not any other information. And that is the content of that comparison theorem. And then, of course, I will always put these notes below in the description below the videos that I upload on the YouTube, okay? But there are two theorems that I want you to know. We prove them, it's good to know, and then you can use them. So one of them, I call them P integral of type 1. By P integral, I mean an integral whose integrand is 1 over x to some power p and dx. And then I have a to infinity. So first of all, do you know that this is an improper integral because the interval of integration is not bounded? On the other hand, what type of improper integral is that? This is a proper integral of type 1 if I assume a is positive. Yes? Because if I assume that a is negative, then what happens? 0 is also in that interval, so it means that this function is also not bounded. Then I have a mixture of these two improper integrals. So it is natural to consider that a is positive, and then I have this integral from a to infinity. So this is called a P integral. So the P integral, this word refers to the integrand, 1 over x to the power of p. I call it a P integral. The claim is that this integral is always clear for us, okay? It diverges to infinity. Okay, this is a sloppy way of saying the writing, but I mean this integral diverges to positive infinity under this condition that p is less than or equal to 1, okay? And then it converges to a to power 1 minus p, p minus 1 if p is greater than 1, okay? So this is very useful. You will see why. So this is, let us prove this and then have it in your memory to be able to use it, okay? And of course, if you forget, the type of the integral you should remember, because the proof is so simple that even if you forget in the exam, you can just immediately derive it yourself, okay? So let us just do the proof. So if I want to talk about this integral, do you remember what I'm supposed to do? So let me be consistent. Here I put plus infinity, so to be consistent here. But whenever I write infinity, I mean plus infinity. So here, if I want to say something about this integral, you remember I use my definition. So definition is that I take the integral from a to a number r of the same function, and then at the end, after the integral is calculated between these two numbers, not infinity, then I send r to positive infinity. Yes? Okay, but this is a simple integral. So what I do, let me call this one I integral, which depends on r. So let me calculate r first. So this becomes, I bring it up. This is a very simple and normal integral. So it becomes x to the power of minus p dx. And then you know what is the integrand of this function. It becomes x to the power 1 more divided by the same number. And then it is supposed to go from a to r. And then when I put r here, so this becomes r to the power of 1 minus p divided by 1 minus p. And then I put a here, so it becomes minus. Yes? So that is the integral. But now, if I want to go back to my question mark, so my question mark will be the limit of I of r, yes? When r goes to infinity. So then I have to consider two scenarios, because you see that if p is greater than 1, it causes that the exponent becomes negative, and then this number will go to the denominator with the positive exponent. So it is important to differentiate between two cases. One case, what happens, if you want, we can also differentiate three scenarios. First of all, you see that p cannot be equal to 1 here, but of course, be careful. This calculation is valid only if p is not equal to 1. I forgot to say that, because if p is equal to 1, I will be in trouble here. So this formula is only working, so let me write this. Let us assume that p is not equal to 1 for the time being. Okay, so I'm on the safe side. P is not equal to 1. So there are two cases that I have to consider, p greater than 1 or p less than 1. Okay, so this becomes equal to, if p is less than 1, what happens? If p is less than 1, okay, can you tell me what happens? If p is less than 1, by the way, this is a constant because the variable of the limit is r. So this is not sensitive to r. This part is only sensitive to r, and I am sending r to infinity. I am assuming that p is less than 1. When p is less than 1, this exponent is positive. So I have r to some positive exponent divided by a number, positive number, but I'm sending r to infinity. Do you agree that it becomes infinity? Yes? And this is a number, infinity minus a number, so at the end it becomes positive infinity. So, okay, that is at least partially we did this part. We didn't consider p equals to 1 yet. But what happens if p is greater than 1? Then what happens, I can write this like this. I can write 1 over 1 minus p, and then I bring it down. It becomes r to the power of p minus 1. Because when I bring it down, I have to multiply the exponent by a negative sign. It becomes this. But now I'm assuming that p is larger than 1, so p minus 1 is positive, so it remains in the denominator, and I am sending r to infinity, so it becomes 0. Agree? So this becomes 0. So this will go away, and this minus sign I multiply it in the denominator, so this becomes this. So if p is greater than 1, I really get this answer. If p is smaller than 1, I get infinity. What happens if I have p equals to 1? If I have p equals to 1, I cannot do the calculation like this, because if p is 1, then my integrand becomes 1 over x, and the integral becomes ln of x. Yes. So what happens if p is equal to 1? Then it means that the question mark is actually equal to the integral from a. So let me write. Then IR actually becomes what? Becomes integral from a to r 1 over x dx. This time it becomes ln of absolute value of x from a to r. And then if I put these numbers there, so this becomes ln of absolute value of r minus ln of absolute value of a. But then I take the limit and send r to infinity. When I send r to infinity, ln of infinity is again infinity. So it means again it becomes infinity. So for the case that p is less than 1, the answer is infinity. If it is 1, that is also infinity. So I can combine them into one formula and conclude the same thing that I had written there. Okay? Any questions here? Okay, for example, if I tell you what is your opinion about this integral, do you think it converges or diverges? What do you think about this integral? Convergent or divergent? You just see that this is a p integral because the number here is 2 and 2 is positive, that's okay. And then that's infinity. So what is my p? P is 5, it is larger than 1, so this means that this is convergent. Okay, if you want, you can also find its value. So you put them in here. Instead of p, you put 5. Instead of a, you put 2, and then you get a number. So that number is the value of this integral. Yes. What about this one? For example, 3 to plus infinity 1 over the third root of x dx. What about this one? Is it convergent or divergent, and why? It is divergent. Why? Because this third root is another name of what? So this can be written simply as integral from 3 to positive infinity 1 over x to the power of 1/3 dx. Yes? And now if I ask you, is this a p integral? You would say yes. What is p in this problem? It is 1/3. And 1/3 is smaller than 1, so it diverges to infinity. Yes? So this is divergent, but this is convergent. Yes? Is that clear? Okay, now let me ask you this question. You know that this is convergent. What is your opinion about this? Let me make it 10, okay? What is your opinion about this? So here, this is one of those cases that calculating the integral, if possible, it's hard. Okay, and they haven't asked you if this is if this is convergent, find its value. They are asking if it is convergent or divergent. You just want to answer this. So now my question is that how do you answer this question? Is this integral convergent or divergent? So convergent based on what? No, okay, p is greater than 1, but this is, if you write something like this, they will not accept it from you because this integrand, this is not a p integral yet. In your mind, you are comparing this to what you know, which is a correct thing to do, but you have to elaborate on that, okay? So it is not exactly x to the power of 5. This theorem in mathematics, when you prove something, that only works for exactly the same condition. Okay, I have not the same exact condition. Yes? No, at least I don't see it. Okay, factoring x to the power of 5 plus 10 is a whole new story. And that's exactly the reason. Sometimes the integral is hard to calculate, but convincing oneself that it is convergent or divergent using this theorem and the comparison theorem is simple. So what we say is that, do you agree with this one or not? On this interval from 2 up to infinity, do you agree that this is indeed the case or not? So why is that? Because the numerators are the same. The denominator of this one is larger than the denominator of this one. So it means that the whole fraction is smaller than that fraction. Yes? And then if I ask you what is your opinion about the integral from 2 to infinity of that function, based on this theorem, you know that the integral, the bigger integral, converges. So this implies that the smaller integral also converges. Is that clear? So this you have to write. So you have to write that on this interval, I know that this is the case. By the way, that is also positive because I need that. Yes. And then I would say that, okay, the larger integral, the bigger integral based on this theorem is convergent. So this theorem implies that the smaller one is also convergent. But if you tell me what is its value, I don't know. But something I know. The value of this integral, whatever it is, lies between the integral of 0, which is of course 0, and the integral of that one. We already, I think, calculated that. No, but we can calculate it. If I put 2 here and 5 instead of p, so it becomes minus 4 divided by 4. So this becomes 1 over 64. So if you calculate this integral using this formula, the answer is 1 over 64. What I know is that the integral of this, whatever it is, lies somewhere between 0 and 1 over 64, but I don't know the exact value. Yes? Is the logic clear? Okay. Let me give you... Pardon? Pardon? Yeah, this one converges based on this, but you have to write all the things that I mentioned on the paper. Okay, so this integral converges. This one is smaller than that one, so the integral of this one also converges. Okay, this sometimes I want you to have this experience. What about this one? Okay, to infinity, and then I would write the same thing. Okay, but let me, for example, write x to the power of 5. Instead of plus 10, let me write minus 10. Okay, so what do you think about this? What is your intuition first? No, my question is that 2 to the power of 5, fifth root of 2, this is on the safe side, yes, because 2 doesn't make any problem. This becomes 0 when x is the fifth root of 10, which is, of course, smaller than 2. Yes, so it is not included. No, I'm on the safe side. But the point is that what is your opinion about this? Do you think it is convergent or divergent? Yes? No, I'm asking you. No, I want to show you that whenever this is negative, I have some problems. You need to know how to solve it. Yes. But I'm just asking you about the feeling, yes, because when x becomes extremely large, it doesn't matter that much if you're adding 10 to it or subtracting 10 from it, okay, if that x becomes extremely large. So it's still, your intuition might tell you that this is convergent. Yes, but I cannot follow the instruction. You see what is the difference? So if I write 0 is less than or equal to x to the power of 5 plus 10 minus 10, this is still true because x starts from 2. When I raise, so x is greater than 2. When I raise it to power 5, it is greater than 32. So still this is positive. But the point is that, do you agree that I can write this? This time I cannot, because x5 minus 10 is smaller than this one, okay? So this is not the correct inequality. The correct inequality, if I want to write it immediately, this is the correct one, okay? But then everything remains silent. Why? Because I know this is bigger than that one, and this integral is convergent. I have something bigger than a convergent. I cannot conclude anything. Is that understandable? So if the bigger one is convergent, you can conclude that the smaller one is also convergent. Okay, so you see that this is wrong. Okay, in this case, the bigger one was convergent. I was able to conclude the smaller one is convergent. This inequality is wrong. What is the correct inequality? The correct inequality is this one, but then I will be again in trouble, because even though this inequality is correct, but I cannot conclude anything, because the right-hand side, the smaller one is convergent. I cannot conclude that the bigger one is also convergent. Do you see the trouble? Yes? So if you write it like this, of course, it is totally wrong. But if you write the correct version, then you cannot use the theorem. So you need to have some experience. Can you know how to fix the problem? Yes? Yes, that is in theory. 100. So let me tell you. So you want to tell me that 1 over x to the power of 5 minus 10 is smaller than what? To the power of 4th. Okay, but then yes, if you can convince yourself of that, that is true. Yes, but how did you brought these numbers? Okay, but still you have to convince people mathematically. Yes, might be your intuition is correct. I don't have anything against that. If you want to check this, so what you can do, you can multiply 100 x to the power of 5 minus 1000. You have to convince that this is actually greater than or equal to x4, yes? If I can show that, which in principle seems to be right. Yes or no? But still, I would recommend you to make this smaller, not bigger. Yes, because you want to subtract as much as possible, as low as possible. Yes, okay. But this is one, I don't know. You have again, you have to convince this. But what I was thinking that you can do something like this: 1 over x to the power of 5 minus 10. What I do, instead of 10, I write some expression in terms of x itself. So what I do, I would say that this is less than or equal to 1 over x to the power of 5 minus 1 over 2 x to the power of 5. Okay? So is that, first of all, let us try to convince you if this is true or false. Do you agree that this is true? Because if I want to show this is true, I have to convince you that the denominator of this one is greater than or equal to the denominator of that one. Do you agree? If I can show you this, then I am done. Yes? But is it true or not? Let me take this x5 away and then multiply by a negative sign. It becomes 10. Then I have to flip because I multiply by a negative sign. It becomes 1 over 2x5. And then I multiply by 2. This means that 20 is less than or equal to x5. Is it true? Not always. But in this interval, it is true. Because I start from 2. Yes? And the minimum value for x5 is 32. So it is automatically larger than 20. Okay, so that's also one way. But this is immediately proven, so you don't need to do something else. So this, I was able to show that this is correct. On the other hand, of course, it is non-negative because x5 is larger than 32. And then, but this can be simplified. What is the answer? So this means that it is less than or equal to 2 over x5. Because this becomes 1/2 x5, 2 goes up, I get this. Yes? And now I have this integral is smaller than this integral. This can be written as 2 times 1 over x5. But we already know that the integral of 1 over x5 on that interval is convergent. It means that that's a number. I multiplied by 2, that's also a number. So this means that the smaller integral is also convergent. Okay, so sometimes if you have this nasty subtraction number, so think about this. You have to change your inequality in a way. And I think that would be good if you write something about this number in this form so that you can use the interval that you are integrating. Yes? Okay, so that is also something. But let me, by the way, let me interpret this P. I want to give you some intuition. So your intuition that you mentioned is correct. If you want, you can write a rule of thumb that is not precise, but what is this P? P is the degree of the denominator minus the degree of the numerator, if you want to get a feeling before doing because it is very important. You need to know, is it convergent? You need to have a feeling about convergence or divergence so that you know how to proceed. Because if you think that your integral is convergent, you have to show that the integrand is smaller than a convergent integral. If you feel that your integral is divergent, you have to change your strategy. You have to show that your integrand is greater than a divergent integral. So it is very important to have a feeling in the beginning so it guides you in which direction you have to go in. Yes? So this is a good rule of thumb. Just this P is the degree. It's a little bit vague idea because degree only works for polynomials, but I will tell you what it means. So the degree of numerator, the degree of the denominator, sorry. So denominator, so let me write denominator, minus the degree of the numerator, okay? So this is something, it's a scratch work, so you just think in this way. For example, here, that is the same story. The degree here is 0 and the degree here is 5. So the difference of degrees is 5 and 5 is greater than 1. So that was a rule of thumb that I immediately understand that the integral should be convergent. Yes, that also works here as well. Okay, let me give you some examples to improve our methodology here. Okay, so what is your opinion about these integrals? Convergent or divergent? Integral from 2 to infinity, x squared plus 1 plus square root of x divided by x square root of x plus x squared dx. Okay, we just want to answer this question. Is this integral convergent or divergent? Okay. Okay, can I use this rule of thumb somehow? Yes, we go and try to see which term will dominate in the numerator when x becomes large, okay? So x squared is the highest power there. And which one will dominate in the denominator? Again, x squared is the highest one. So the degree of the numerator is 2. Of course, I cannot talk about the degree of this because this is not a polynomial, the square root of x. But the dominant term is x squared, and the degree of that is 2. This one is also 2. And if I subtract them, it becomes 0. Okay? So 0 satisfies this condition. 0 is less than 1. So in principle, my intuition should be that this integral diverges. Okay? And if this integral is supposed to diverge, then I am not confused. I focus my energy to show that this is greater than something which is divergent. Yes? So this is, now I want you to know how we can do that. So you see, it is actually very important, because if you just want to randomly play out with these inequalities, it will not work. But now we have some idea. The idea is to show that this integral is divergent. So I do not go for less than or equal. I will go for greater than or equal, because I want to show divergence. Okay? So I will try to make this greater than or equal to an expression, but the integral on the right should be divergent. If I can fix everything that I said, then I can come back and conclude that this integral is also divergent. Okay? So can you tell me what to do? Try to keep these high powers as much as possible there. For example, I keep this one and I write this. Do you agree with this one? Yes? I just try to keep this one. I throw as much as I can away. Okay? So this is correct because I kept the denominator the same and I just throw these things away. This fraction is definitely greater than this fraction because its denominator is the same and the numerator is greater than that. Okay, and then you can see that I can factor an x and simplify. So let us just do that. Whenever you can simplify things and then start thinking again. Okay, but still, I should show that this diverges. Still, I don't know why, so I have to simplify. Again, simplification means to write an inequality like this, not smaller than, okay? So can you tell me what to do? I have already done what I could with the numerator, so what can I do now? Let us tamper with the denominator here. So I keep the numerator the same. Can you tell me what to do? A square root of x, if I write square root of x, then I will be, but that's also good, yes? In this case, even a square root of x also works, yes? You are right. What, this is correct or wrong, by the way? This is wrong. Yes? Because the denominator is bigger, so it doesn't work. So you need to write something which works, not what you like, yes? Yes. So what should I write there? Speak louder, please. Yes, but what can I write in the denominator just? I want to keep the numerator the same. Do you agree that if I write x plus x, yes? Because uh, square root of x plus x and x plus x, which one is bigger? X's are the same, which one is bigger? Square root of x is bigger or x? I am working from 2 onwards. So x is bigger. So this means that this right-hand side is bigger than that one. Yes? So it means that this fraction is bigger than that fraction because its denominator is smaller. When the denominator is smaller, the fraction is bigger. So what I have written is completely true. Okay? But then this is extremely simple because this becomes 1 over 2. Yes or no? So I was able to show that whatever this is, on that interval that I am working, this is larger than 1 over 2. But now integral of 1 over 2. What is integral of 1 over 2? From 2 to infinity. What is this integral? Convergent or divergent? What is that? This is also a p integral. Why? You can write it in this way. Yes? Because here p also can be 0. It is not actually, it's also including 0. So in the case p is 0, this is divergent. Yes? Or if you want, this is so simple that you can calculate it because this integral is 1/2 x, and then you are going from 2 to r, and then at the end you are supposed to send r to infinity, so it becomes infinity. So I was able to show that whatever this is, on this interval that I am working, it is greater than or equal to 1/2, and the integral on the right-hand side is diverging to the infinity, so it means that the bigger one also diverges to infinity. So this integral is divergent. And that is according to what we, by that rule of thumb, discovered before continuing. So it is, by the way, crucial. Because if you don't have a feeling, you don't know to make the fractions smaller or to make the fractions larger, yes? So this rule of thumb helps you to have some guess and then continue your guess. Yeah, is that clear? But I say that I myself hate these problems. They are not that easy sometimes. Yes. Okay. So let me give you some more examples. Uh, so integral from 10 to infinity, x plus ln of x over x to the power of 2 dx. So what is your opinion about this? By the way, you can think about this. Calculating these integrals, I don't see any, might be they are impossible, or if they are possible, they are not very standard, okay? If you can immediately calculate this integral, that is probably one of the best ways. You calculate the integral and take the limit. But most of the time, they are giving you integrals that are hard to calculate or even impossible, and they are asking about if the integral is convergent or divergent. So what is your opinion about this? Let us use that rule of thumb to get the feeling about this. So how do you think about this? So you will go in the numerator, which one will dominate for big X? So x will dominate ln of x, ln of x. So x always is dominating ln of x. So in principle, the numerator is just x, and the denominator is x squared. So the difference between degrees is 1. Yes, because the degree of the numerator will be 1, the degree of the denominator is 2. If subtract them, it becomes 1. So what is your guess? It should be divergent because p is 1. Yes, but so it means that when it is divergent, you need to write something here so that this one is bigger than that one. So you will start your solution by saying that, okay, which one is it is extremely, by the way, simple. So can I write, what do you write here? So first keep the denominator the same, don't touch it, okay? So what can I write for the numerator? It's extremely simple, by the way. What? No, you can write, of course, ln x. If you write ln of x, it is not wrong, yes, because that is a correct inequality. But then you will be a little bit in trouble about ln of x over x, okay? X is better. Keep the one that dominates. Try to keep that one which dominates, okay? So this is greater than that one. Do you agree? But you have to be careful about it. Why? Because ln of x on this interval, when x is greater than 10, then ln of x is greater than ln of 10. So, and that is positive. Yes? So I can actually do that because the numerator is bigger than the numerator. And what is the answer, by the way, here is 1. Yes? Okay, so what is your conclusion? This integral is greater than the integral of 1 from 10 to infinity, but integral of 1 is divergent. Yes? Because integral of 1 dx, okay, from 10 to r becomes simply r minus 10. And when I take the limit and send r to infinity, it becomes infinity. So the smaller one diverges. It implies that the bigger one also diverges to infinity. Yes? Yes? Okay. Thank you very much. So why are you silent? Yes, so my mistake, but this will not change the result. But thank you very much. So this becomes 1 over x. Yes, but 1 over x is also a p integral. But what is p in this case is 1, and it is divergent, so this calculation is wrong, but I don't need it. So because I know that this integral is a p integral where p is 1, and in that case it diverges to infinity, so the bigger one also diverges to infinity. Thank you very much. Any questions? Okay, let me give you another one. What about this one? Integral from 30 to infinity, x square root of x plus x divided by 1 minus x cubed dx. Okay, first tell me your feeling. Do you think it should be divergent or convergent? What? Convergent. Why? Because the degree of the numerator, by the way, is how much? The degree. There is no degree here. Which one will dominate? No. This is the product. X square root of x, the degree of x is 1. The degree of x square is square root of x is 1/2. So if you add them, it becomes 1 plus 1/2. Yes? So the degree is great. This will dominate over that. But in the denominator, x3 will dominate. Okay? So we know that the degree of the numerator is 3/2. Yes? And the degree of the denominator is 3. So what is the difference? Is 3 over 2. Yes, 3 over 2 is greater than 1. So our guess is that this should be convergent. Yes. When it becomes convergent, we shouldn't start writing that inequality in the greater than or equal. We have to write smaller than or equal. Yes. So this will give you the guide. Yes. May you speak louder because this is in my ear. I don't hear you properly. Yes. So I actually try to check which one will dominate, and try to subtract the degrees to get a feeling in which direction I have to go, because they are completely opposite directions. If you spend some time, it doesn't work, you have to cross everything over and come back to do the other thing. Yes, because it's always better to have some certainty about in which direction we are going to, and then in that case we can actually go for it and then try to use our logic in a way that I want to reach my goal. Okay, so now we understand that somehow this integral should be convergent. So this means that my goal will be like this. I mean that this is a scratch paperwork, yes? I ask myself, can I conclude that this one is smaller than a question mark, but this time the question mark, the integral of question mark has to be convergent. If that question mark is not convergent, it is useless. Yes? Is the logic clear or not? Yeah, okay. I don't know, what do you think? How should I go? To be honest, I don't like this negative sign here. It's always distracting. I prefer to have the negative sign of 1, okay? So I take a minus sign out, okay? So I don't know, might be that is you don't have any problems with negative signs, but negative signs are always bad, okay? But my question is that I can only work here, because if this integral converges, its negative also converge. Yes, and if it diverges, its negative also diverges. Yes, so this negative sign doesn't have any problem here. So I can focus my energy only on this integral. Okay, now we know what to do. We want to make this smaller than something. Okay, so how should I do that? The denominator is that -1. It is similar to that -10 that I described. So if you don't mind, let us do this next. What can I do for the numerator? I want to write something. Let me keep the denominator for the time being as it is. But I want to write something here so that this one is less than or equal to that one. So what can I do? No, what? Why? Like this? Now, what is the benefit of that? Yes, that is right. This is smaller than 2 times of that. But then the problem is still the same. I want to do something so that I can get rid of them and somehow compare them with these p integrals. So that is my goal. Yes? So this is, even though that is true, but that is not helpful, because my goal is to be able to simplify things. Okay, so I want to make this one something. So how do you write this? Pardon? So what should I do? This is, yeah? So you mean this? Yes? Yeah, this works. Let us follow your strategy. So what you are saying is that this one is smaller than that one. That's correct. Yes, because x square root of x is larger than x, and this is the same thing. What is the benefit of that? The benefit of that is at least I can combine them into one single term. Yes, and then x to the power of 3 minus 1. Okay? Okay, and then I have to get rid of this 1 some way. Okay, so and I told you I told you what to do. So what you do, you can write this 2x, you can write this one as it is, and then instead of 1, if you learn what I told you, you can write this Do you agree with that? Or no? Yes or no? Because on that interval, x, but I have to be careful, by the way. I think this is not correct. Yes? But this is correct. Yeah, that is correct, yes. Because because if this is going to be correct, it means that x3 minus 1 should be larger than x3 minus 1 over 2 x cubed. Do you agree? If I can show this to you, it means the denominator of this one is larger than the denominator of that one. And then it means that the fraction itself is smaller than this fraction. But that is trivial, yes? Because this x3 and that x3 are gone. Let me multiply by minus 2, it becomes 2. It becomes less than or equal. This becomes x to power 3. Is this true? Yes. On this interval that I am working, the minimum value of x is 30. So definitely this is true. Yes? And then we continue. So this becomes 2x square root of x, and in the denominator I will have 1 over 2x cubed. So I simplify this, 2 goes up, it becomes 4 square root of x, and then this and x are cancelled, so it becomes x squared. But what can I write this? It can be written as x to power 1 half, and then I have x to power 2, so this becomes 4x to the power of 3 halves. So I achieved the goal, yes? So what I did is actually proving that this fraction, whatever it is less than or equal to the last fraction. Yes, but that integral of this expression is a p integral, yes? If I go from 30 to infinity and compare it with this integral, I hope that you agree. This is a p integral, 4 times a p integral, but p is how much? Is 3 over 2, is exactly what we guessed. Do you remember? That was 3 over 2. So p is larger than 1, so the integral is convergent. The bigger one is convergent, so this means that the smallest one is also convergent. Might be you can come up with another idea for the numerator yourself, but I think that was probably the best choice. Yes? Pardon? Yes? No, I'm asking myself. First, I wrote what I want, then I want to prove what I have done is right. Okay? So I am claiming that this fraction is smaller than that fraction. The numerators are the same. I have to convince you that the denominator is larger than the denominator. Yes? This one? That is the experience that I told you there for minus 10. Do you remember when I was teaching you, I told you that this minus sign, do you remember? I told you, I talked about this negative 10 and 10 here. Exactly, and then if you see, I solved this problem on the board by writing something like this. Yes? So this will work. If this number is not good, then you can change this number, but it doesn't change that much. So the trick is that whenever, if it was positive, I was actually very happy, because if it was just x3 plus 1, I don't need to do that. I can just simply drop 1. Yes, but in this case, I cannot drop 1, because by dropping 1, I am making the denominator larger, but I want to make the denominator small. Yes, is that clear? Okay. So actually, if I want to give you another rule of thumb, is that the dominant term was x square root of x. The dominant term was x to the power of 3. This should be in your mind. You have to have, somehow you should make something that in the numerator the dominant term appears. Okay, and in the denominator the dominant term appears. So if you see, I am following that logic. Yes? So, and then, of course, this was probably the best choice that you mentioned. Any questions? No? Okay. Yes? The dominant term, which one is, I mean by going to infinity, one is stronger than the other one. One becomes larger than the other one, yes? The one with higher power of x becomes more significant when x becomes large. So this x times square root of x is x to the power of 3 over 2. But this x is x to power 1. So this power is larger than that one, so this will dominate. And in the denominator, x3 will dominate. Yes? So this means that your strategy should be like this. Try to write inequalities in a way that in the numerator only the dominant term survives and in the denominator the same. So that you can get what I want to have one term. The problem here is that I cannot simplify things. Yes? So the idea is to make them in a way that I keep the dominant terms, but in a way that I can simplify and finally reach to a p integral. Okay? That's the only point. So this should be in the back of your head. Okay, so still the word is not finished, so if you don't mind, let me continue a little bit. So let me jump to this problem, exam question. So let me solve this one as well. So exam 2018 and then 0108 and then question number 7. This is extremely simple, okay? So you want to see if this integral diverges or converges, okay? Just do it quickly. What is your feeling about that and how should I achieve the goal? Convergent or divergent? It should be convergent, yes? Because what is the difference of degrees? The degree of the denominator is how much? It is, you cannot say the degree, but then there is a nominal degree for that. What is that? 3 over 2, yes? And what is the degree of the numerator? 0. If you subtract them, it becomes 3 over 2, and 3 over 2 is larger than 1. So according to that p integral theorem, it should be convergent. When it becomes convergent, then the strategy becomes clear. What should I do? I have to make it smaller than or equal to something. For the numerator, I cannot do anything. But for the denominator, what can I do? What can I do? Again, this negative sign. Yes, negative 1. Yes. So I have troubles with this negative 1, but you know what to do with that negative sign right now. You can write it as like this. Yes? Is that understandable? Because again, the same story. X3 minus 1 is always greater than x3 minus 1 half x3 on this interval. Yes? And then this is easy now. Because this becomes 1 half of x3, 1 half goes up, and this becomes this. But this can be written as a square root of 2, x to the power of 3 over 2. And then the right-hand side is a p integral, where p is 3 halves, so it is convergent. So this means that this also converges. Yes? Okay. For example, this is an exam question. 2017 as 1024 question number 4. Yes? So you are supposed to show that this integral is given to you. IP is integral from 0 to infinity. And then you have x over 1 plus x squared to power p dx. You want to show that it diverges if this is the case. So you want to show that this integral diverges if p satisfies that condition. So how should I prove this? Okay, so do you think it will work in this case? I don't know. P is somewhere between 0 and 1. You want to convince yourself that this is why it diverges. Okay, you should have a clean strategy for me. How many which values? No, 0 is excluded. 1 is of course included. P1, yes, I agree with you. But do you know how? Let us follow your strategy. So you say that let us take P equal to 1, yes, to see how it goes. Okay, if P is 1, then my integral becomes integral from 0 to 1, x over 1 plus x squared dx. This shouldn't take you some time to understand what to do with this one, because this is one of those integrals. It is very famous and you should know how to calculate it. Yes, because the derivative of 1 plus x squared is 2x, which appears in the integral with a scaling factor, up to a scaling factor. So this means that this is actually, you can calculate this. How? By method of substitution. So first of all, what you do, you define it as the limit of integral from 0 to r, and then you have x over 1x squared dx, and r goes to infinity. Okay, so let me take this one as IR and calculate this IR. So IR is easy to calculate. How? I need to take 1 plus x squared to be a new variable u, and then 2x dx becomes du, and then I want x dx, so I divide by 2, x dx becomes 1 half du. But then x goes from 0 to r. This would then imply that u goes from where to where? If x is 0, u becomes 1. If x is r, u becomes 1 plus r squared. Yes? And then what happens? IR becomes integral. Instead of 0 to r, I write 1 to 1 plus r squared. Instead of x dx, I put 1 half du. And instead of this, I just put u. Okay, and then I calculate this integral. That is very famous. It becomes ln of absolute value u. It is between 1 and 1 plus r squared. And if I calculate that, so IR becomes equal to 1 over 2 ln of, if I put 1 plus r squared here, I don't need absolute value because that's already positive. And if I put 1 here, ln of 1 is 0. So that is my IR. Okay? And then I have to take the limit of IR when r goes to infinity. It is extremely simple to see that also becomes infinity. Yes, so actually I calculated that and I realized for the case of p exactly equal to 1, I achieved the goal. The integral is divergent. Okay, but what happens for the other values? Because there are infinitely many values involved. Of course, I cannot do it case by case. So I should have a strategy. So can you tell me how should I continue now? What happens if p is not 1, is exactly between 0 and 1? So what happens if I have this scenario? Okay, let me ask you this question. How do you compare this one? If p is strictly between 0 and 1, how this and this are related? If p is strictly between 0 and 1, which one is bigger, if any, for sure? The right-hand side is bigger. You are right. Why? Because if you have p between 0 and 1, it acts like a root or a third root or a fifth root or whatever, okay? So it means that if p is between 0 and 1, I hope that you agree that 1 plus x squared to power p, because p is less than 1, is less than 1 over x squared. Yes, because the power of this is actually 1, and p is less than 1, so that is correct. But then I find the reciprocal. It becomes 1 plus x squared to the power of p. I have to change this sign, and then I have to write this. So this means this expression is larger than the expression. And then I multiply it by x because I am sure that x is positive in this interval that I am working. So this is true. So this means this is larger than this one. But I already showed that this is for the case P1, it is divergent. And this one is bigger than that one. So again, this will also diverge to infinity. So that is a good, it is not a standard problem. So you need to consider p equals to 1 separately. And then if you solve p equals to 1, because other p's makes this integrand larger than this one, and you know already that this is divergent, so it means that the rest of these p's will also make the integral to diverge. Yes? Is that clear? Okay. So you can have a little bit of break so that I can clean the board. Pardon? Yes, yes, of course. Okay, so let us continue the lesson. There is also another question. I thought this is a good question here. It's question number, this is an exam question, 2021, 03 and 11, Q5. Yes. So I can also show you, I don't know why I forgot to actually scroll this down. So this is this question. Okay, so we want to show that this integral converges. The integral is integral from 1 to infinity, and then you have 2 over 2x squared plus sine of x plus 1 dx. Yes, this is your integral. You want to show that this converges. Of course, you could feel that this is convergent. Why? Because 2 is the only term in the numerator, but when x becomes extremely large, it is clear that 2x squared will dominate. So this becomes 1 over x squared, and 1 over x squared is actually convergent. So even if they haven't mentioned that this is convergent, you need to understand it yourself. But, okay, so the first part is actually more or less done. So what can I do? I want to show that this is convergent. So what I am supposed to do, I am supposed to write 2 over 2x squared plus sine x plus 1. I have to make it smaller than a fraction that I'm sure it's convergent. For the numerator, I just copy and paste 2. But what can I write for the denominator? Your goal is to have 2x squared. But do you think I can simply write 2 squared and be happy or not? Can I? Yes or no? Yes, why? Exactly. So this sine x is somewhere between 1 and minus 1, yes? And if I add 1 to it, it becomes greater than 0. 1 plus sine x less than or equal to 2. So definitely this is a non-negative number. When I add it to x squared, it becomes larger than just 2x squared. So when the denominator becomes larger, the whole fraction becomes smaller. So what I have written is completely correct. Yes? And then 2 and 2 are cancelled. So it's 1 over x squared. That is the famous p integral, where p is 2 larger than 1. So this means that this integral converges. It implies that this integral also converges. So that is the easy part of the question. But the second part is actually a good question. So find an approximate value for the integral for which the error is not larger than 1 over 8. Okay? So the first part was actually very simple. How do you think you can do that problem? You want to estimate this integral. You've already found an upper bound. Of course, it is not a number, but you already found a function which is larger than this function, and you know how to integrate it from this one and to infinity, because that's a p integral. But if I want to have an estimate for my integral, I have to have an upper bound. I should also have a lower bound so that I tell you that integral lives between these two numbers. This will give me an estimate. Yes? And that is also extremely simple. So the person who designed the question actually thought very beautifully, actually. So can you tell me, what can I do now here? I can keep 2 here. So what can I write for the denominator? Look here. What can I write? So 2x squared. Do you agree if I write 2, that's correct? Yes, because 2x squared plus 2 is always larger than 2x squared plus sine x plus 1, because the maximum value of sine x plus 1 is 2. So this means that 2x squared plus 2 is the maximum value for this. So this means that the denominator here is greater than the denominator here. So the whole fraction is indeed smaller. Yes, understandable? Okay. And then I can simplify these 2's. I can divide everything by 2. So that's good. I have an estimate. And I think this is famous. This should be famous for you, this integral. That integral should also be famous. So this means that integral from 1 to infinity, 1 over x squared plus 1 dx is less than or equal to the given integral from 1 to infinity 2 over 2x squared plus sine x plus 1. And then it is less than or equal to the integral from 1 over x squared dx. X goes from 1 to infinity. Okay, so now let us calculate these integrals. So let me call this one I1. Let me call this one I2. So we don't have any problems with calculating these integrals. So what can I do? Integral from 1 to infinity, 1 over x squared dx. I can write it as the limit of integral from r to 1 to r, and then I can bring it up. So let me just write this, is a very famous one. Yes, and r goes to infinity, but the integral of this one is minus 1 over x, a primitive function. It goes from 1 to r, and then I take the limit and I send r to infinity. But if I put r here and send r to infinity, it becomes 0, and if I put 1 here, so the answer becomes 1. Yes, and I do the same calculation for I2. I2 is the limit of integral from 1 to r, 1 over x squared plus 1 dx. R goes to infinity. But that is also a famous integral. That is arctangent, yes? So this becomes the limit, r goes to infinity, arctangent of x. X goes from 1 to r. So this becomes arctangent. So let me continue here. So it becomes equal to the limit of arctangent of r minus arctangent of 1 when r goes to infinity. But arctangent of 1 is pi over 4. Arctangent of infinity is pi over 2. And pi over 2 minus pi over 4 is pi over 4. Yes? So if I call my integral, my original integral, to be j, then I showed that whatever j is actually lying on this interval. Yes? But I want to give an estimate for this integral. I know it lies somewhere between pi over 4 and 1, but I want to give, according to the problem, an estimate so that I am sure that the error that I am making is not larger than 1 over 8. So how can I do that? So assume that this is the axis, real axis. So 1 is here. Pi over 4 is how much? Is 3.14 approximately divided by 4, so it is definitely smaller than 1. So here is 0. I don't need to write 0, so let me write pi over 4 here. I'm exaggerating a little bit here. I know j is somewhere here. For example, assume that j is here. Okay? You want to give me a number for j so that, for example, can I say 99? It might happen that j is indeed 99. So for example, if I say 99, I don't know how much error that I am making. Yes? Because I don't know the exact position of j. I know that j is somewhere between these two numbers. If I say that, okay, let us take 0.99, there is no guarantee that the distance from 0.99 to my integral is less than 1 over 8. I have to confirm that somehow this is correct. So how can I do that? Yes? I don't have, might be Taylor expansion, but Taylor expanding these things are not that easy. Yes? Yeah, it is extremely hard. But you don't need to do that. Let me ask you some question. What is the length of this interval? I know that j is somewhere between these two, but what is the length of this interval? It is 1 minus pi over 4, agree? Which is 4 minus pi over 4. Okay? And if I divide this by 2, it becomes this number, which is exactly where, no, this is not correct. No, so I want to make it as, I want to make sure that this is smaller than 1/8. My claim is that if I take the midpoint in this case, it will work. Where is the midpoint? The midpoint is the sum of these two numbers divided by 2, so it becomes 1/2 plus pi over 8. Okay? I am claiming that wherever this j is on this interval, this distance is always less than 1/8. Okay, I don't know j where j is, but can I prove my claim? Yes or no? Can I prove the claim? I think we can, because if I divide this by 2, because I want to find there is this radius, this distance. If I divide, because the total length is this number. If I ask you what is this length or what is that length, this length would be 4 minus pi over 8. Yes? That is this length. And the distance from j to the midpoint is definitely smaller than this number. It cannot be larger than that number, yes? Because this number is the midpoint, yes? And if I ask you what is 4 minus pi divided by 8, this is this length. Do you agree or not? This is that length. And j is somewhere here in this interval. Wherever it is, its distance to this number is less than 4 minus pi over 8. Agree or not? So the distance, how should I show the distance? J minus this number, which is the distance between these two numbers, is definitely smaller than this radius. Yes? Is that clear? And this number is less than 1/8. So I achieved the goal. So it means this is the number which is approximately equal to my integral, and the error that I am making for sure is less than 1/8. Yes? Understandable or not? So let me repeat this one. What I showed, you don't have any doubt about this, yes? I proved this one for you. So pi over 4 is here, 1/1 is there, j is somewhere here, I don't know where. So let us just randomly pick that point, okay? So j is somewhere. Okay, and the midpoint is this one plus that one divided by 2, which I get this number. Okay, and if I ask you what is this length is half of the total length. So the total length is this one I divided by 2. And I hope that you agree with me, the distance from this point G, wherever it is, when I consider this point to the midpoint, the distance from that point, wherever it is, to this midpoint is definitely smaller than, if you want, you can put also equality here. Smaller than or equal to 4 minus pi over 8. Agree or not? Okay, and then 4 minus pi over 8 is definitely less than 1/8, because 4 minus pi is less than 1. Yes or no? So that is the midpoint. So this, you can write this number for your approximate. Yes? Yeah. But the one that I think the examiner has mentioned is that, so actually that number is a better number, a more friendly number. He has written that, okay, if j is between these two, because 3/4 is less than this number, I can say that j is between this and that. Then he has thrown this number away and I found the midpoint of these two numbers. It's a better number, of course. Yes? 1 plus 3 divided by 2, so it becomes what? 7 over 8. So the examiner has mentioned this number, 7 over 8. Even if you say 7 over 8, this is working, because if you write 3 over 4, the distance between these two is 1 minus 3 over 4, which is 1 over 4. And if you divide by 2, it becomes exactly 1 over 8. Yes? But mine is probably a little bit safer. But if you want to have the error at most 1 over 8, 3 over 4 also works. You don't need to work with pi over 4. But anyway, the idea is to approximate this integral with the midpoint, and then prove that the midpoint is actually a point that is close to my integral when the error is not beyond 1 over 8. Yes? Okay. The next problem is actually very simple. So let me just skip that one because it's extremely simple. And let me go to the improper integrals of type 2. Yes, so type 2 improper integrals. In this case, the function becomes unbounded. Okay, for example, you have a function, you want to calculate this integral. A and B are just numbers, and you have f of x dx. So assume that what happens when you put the lower limit in the function becomes an unbounded function. For example, you have integral from 0 to 1, but you have 1 over x dx, this scenario. Yes? So you see that the integral is from 0 to 1. It is just a bounded interval. But what happens when I get closer and closer to 0, 1 over x becomes infinitely large. So the function becomes unbounded. Whenever this happens, it means that still it is an improper integral, but this is called an improper integral of type 2. Yes? Okay. So that is one thing. How should I do that? If f at a is unbounded, what you need to do something like this. You need to write integral. You can write what I have written here. Let me show it for you. Integral I can write from c to b f of x dx, and then take the limit and send c close to a, but from the right hand side. So that is the definition. So if you read that, let f be a function that is continuous on this interval, and possibly, that is a typo, it should be possibly unbounded near a. Then the integral from a to b f of x dx is defined in that way. And you can guess what will happen on the next page if I have troubles at b. So what should I do then? If I have my function, if my function becomes unbounded at the upper limit, so what should I do? How do you think to define it? So you should write the limit, and then you write from a, but instead of to b, you write to c, and then I send c close to b, but from the lower values, so b negative. So that is the definition of these improper integrals. Okay? For example, this module question asks you to calculate these integrals. So this is, by the way, be very careful. These type 2 improper integrals are not that clear, because here I don't think you get confused, because as soon as you see infinity or negative infinity, you realize that this is a generalized or improper integral. But for example, they might ask you this question: compute this integral, for example. Okay? If they ask you calculate this integral, that is up to you to immediately realize that is also an improper integral. It is not that clear as the previous type, because in the previous type you see these infinities, you immediately realize that's an improper integral. But why this is an improper integral? Because my integrand becomes unbounded at the upper limit. If I put 1 here, this function is not continuous at 1. Agree? So this means that I have to use this formula. So this becomes the limit. I should write integral. I do not have any problems at 0, so I don't need to change it. I have problems at 1, so I change 1 with a number. So let me write epsilon here, for example, and then write the function, and then send epsilon to this number from the lower values, so from the left-hand side. Okay, and then you calculate this. Again, you have to call this an integral I, which depends on epsilon, and calculate that. So I epsilon becomes equal to integral from 0 to epsilon dx over 1 minus x squared, but this is a famous integral. What is that? It is arc sine of x. It goes from 0 to epsilon. I put epsilon here, so it becomes arc sine of epsilon. Or you can put c, it doesn't matter. Minus arc sine of 0, which is 0. But then the question mark becomes the limit of I of epsilon when epsilon goes to 1 from the left. So this becomes limit of arc sine of epsilon when epsilon goes to 1 from the left. What's the answer? Yes? What's the answer? No. It becomes pi over 2, yes? Because sine of pi over 2 is 1. So this is pi over 2. So we calculated this integral, it becomes pi over 2. So I just want to mention that you have to be careful to detect the second type improper integrals. Also, there is I will skip the second one because that's also very easy. Okay, let us go to a p integral of type 2. That's exactly the same scenario as we did before, but for this type of integrals. So what is that? So integral from 0 to a, 1 over x to power p. You see 1 over x to power p is again a p integral. But this time it goes from 0 to a dx. 0, I have problems at 0 if p is positive. If p is not positive, I don't have any problems with that. I don't know how I have written it here. Yes, I have assumed that a is positive. What about p? Okay, so a is positive, of course. Yes, and then we want to show that this becomes equal to, again, infinity or a to power 1 minus p divided by 1 minus p this time. This happens if p is less than 1. You need to know the conditions are different. Yes, this is the other way around. So this p integral in this case will have these numbers. First of all, 1 minus p and 1 minus p are exactly the same. If you remember, in the other case, it was p minus 1. And in the other case, it was p larger than 1 and p less than or equal to 1. But this is the other way around. Okay, but that's easy to see. Even if you forget, don't worry about it. You can just immediately calculate that. For example, if I want to calculate this, how should I do that? I would say that this becomes the limit of integral. I have problems here, so I would write it from epsilon to a, and I send epsilon to 0 from positive values. So this becomes this. Again, let me assume that p is not equal to 1, and then later I can consider p equal to 1 as well. So this becomes the limit of integral from epsilon to a, and this becomes x to power minus p dx, and epsilon goes to 0 from the right-hand side. So this becomes a limit of epsilon goes to 0 from the right. This becomes x to power 1 minus p divided by 1 minus p epsilon to a. But this is simple, yeah? So this becomes the limit a to the power of 1 minus p divided by 1 minus p, and then minus epsilon to the power of 1 minus p divided by 1 minus p. And then what happens? I want to calculate what happens when epsilon goes to 0 from the right-hand side. Okay? So if p is smaller than 1, what happens? If p is smaller than 1, then this power is positive. So epsilon remains in the numerator, and I am sending epsilon to 0, so this term will vanish. And then this is left. Yes? But if p is greater than 1, what happens? If p is greater than 1, this is a constant, which is not related to epsilon, but this one will go down, so it becomes minus 1 over 1 minus p, and then I have epsilon to power p minus 1. P is greater than 1, so this means that this epsilon remains in the denominator because p minus 1 is positive, and I am sending epsilon to 0 from the right-hand side. So what happens, by the way, this becomes positive infinitesimal, but because p is larger than 1, this becomes negative. So it becomes negative infinity, but there is another negative sign here. So at the end, it becomes positive infinity. Yes? So this means that I was able to show this. You can also show that p equals to 1 yourself. That is very simple. It becomes just ln. Yes? You can calculate that one separately. Any questions here? Okay. And let me solve that example for you. Example 6.10. So we are supposed to talk about this integral. And by the way, the comparison theorem also works for this case. That comparison theorem is actually independent of what we have here. So what we do is integral from 0 to infinity dx divided by square root of x plus x to the power of 3. We want to somehow solve the problem. What type of improper integral is this? Type 1 is clear, but it is also type 2. Yes? Because I have problem when I put 0 there. So this is a mixture of type 1 and type 2. Okay? So if you want to understand if it is convergent or divergent, you have to separate these situations. Yes? For example, I can write it from 0 to 1 dx. This is you can control it, but I think 1 is good in this case. And then plus integral from 1 to infinity dx over square root of x plus x cubed. Now, I wrote this as the sum of two integrals, but this integral is type 2 only. Yes, because I have problem at 0. This integral is type 1 only. I have problems with this infinity. So I have to consider two scenarios. Yes. So first of all, let us try to solve this one, which you are more familiar with. So let me call this one I1, and let me call this one I2. So what is your opinion about I1? Okay, so what is your guess? Convergent or divergent? Convergent, because the nominal degree of the denominator is 3/2, because this will dominate, and 3/2 is larger than 1. I think you are very experienced now for this one. So what I do, I want to go for convergence, so I need to write less than or equal. So what can I do? It's clear. Do you agree that this is less than or equal to this? So yeah, that is just 3. Very simple, actually. Okay. Do you agree with this one? Because x plus x to power 3 is definitely larger than x3 alone. So the denominator is bigger, so the fraction is smaller. Yes? And then can I write that? Yes, because I am working on this interval. X is larger than 1. So that is correct. And then this is a p integral. Do you agree? 1x to the power of 3/2. But you need to write them properly in the exam, but I just want to go through them fast. So do you agree that this integrand is smaller than this integrand? This is a p integral, which is convergent. So this implies that this is also convergent. Yes? So I1 is convergent. If I2 is divergent, we say this is divergent. If I2 is also convergent, then we say this is convergent. Yes? Okay. What about this one? So let us try to investigate I2. So I need to write 1 over square root of x plus x to the power of 3. So this comparison theorem actually works again, but the circumstances are flipped. Okay, so this one is hard to actually, so let us see that, by the way. But be careful, here we don't care about dominance. because we want to see what happens close to 0. So it means that which one becomes smaller if I am getting closer to 0. If I am very close to 0, x to the power 3 is even smaller than x. If you have a number which is very close to 0, when you raise it to high powers, it becomes smaller. So in that case, this x will dominate. Okay? Okay, and when x dominates, it means that what is your nominal degree? What is the nominal degree here is 1 over 2. Okay, and go back to this theorem. 1 over 2 is smaller than 1. In this case, it will converge again. Do you understand the logic? So be careful. This situation is flipped. Okay, so in numbers close to 0, x3 becomes negligible, so x will dominate, and the nominal degree will be x square root of x, which is 1/2. 1/2 is here, so this means that I also guess that this should be convergent. Okay, and then it means that when I understand it is convergent, then I go for this one again. Okay, but do you agree that this one is also less than this? Yes, because x3 is positive. So this denominator is larger than that denominator, so the whole fraction is still smaller. But this one is 1 over x to the power of 1 over 2. Okay, this is this scenario, because this is type 2 p integral. Okay, type 2 integral of that type is convergent. And the smaller than convergent is itself convergent. Okay, so this means that this is convergent, that is convergent, so the total integral is convergent. Okay, are you confused or not? There is nothing to be confused. You know, if you have time, you just sit down and think about them. It is possible to discover them yourself. Yes. If one of them at least is divergent, you don't even don't bother to investigate the other one. You just stop and say that the integral is divergent. But if one of them is convergent, you cannot immediately conclude anything. You have to do the other one as well. Okay. Any questions? Okay. So let me solve this exam problem and then we continue the rest. There is I think the hardest problem is the next problem that we will investigate next session. Okay. So let me just try to solve this one. I think this is easy. Exam 2020 0603, question number 4. Determine whether the following, yes, you have it on the board. Determine whether the following improper integrals are convergent or divergent. If they are convergent, evaluate them. Okay, so let us do the first one. The first one is integral from 0 to 1, e to power minus x over x dx. First of all, is it an improper integral in the first place? Yes or no? Why? Because in the denominator, x at 0 is not defined, it's unbounded, yes? So it is an improper integral, but of second type, okay? So if I want to check this convergence or divergence, either I can use the definition, but if you have a little bit of experience, hopefully you realize that I don't have any clue how to calculate that integral. If you can, you calculate that integral and then send epsilon to 0 and then see if the limit exists or not, okay? But do you have any other ideas? So if there is nothing like that, we have to use this comparison theorem. So what can I do? I would say that x is, okay, first of all, what is your hunch about this? Do you think it is divergent or convergent? Yeah, it's not that easy to, it is not hard, but so let me just write it like this. X is between 0 and 1, yes? So then minus x becomes between minus 1 and 0. And e to power minus x becomes less than e to power 0, and this one is e to power minus 1. Yes? So can you tell me what to do now? Which one is better? Because 1 over x is a famous p integral, but I want p integrals of this type. So what I need are these situations. So what do you say? E to power minus x over x. It is. Do you agree that this is larger than e to power minus 1 over x? Do you agree? Because I just showed that e to power minus x is greater than e to power minus 1. So it means e to power minus x is greater than e to power minus 1. The denominators are the same, so this fraction is larger than that fraction. Yes? But this e to power minus 1 is just a constant. Okay, so it means that the integral from 0 to 1 of this will be greater than the integral from 0 to 1 of this one. But this e to power minus 1 goes out because that's just a constant. Okay, but what type of integral is this? This is a p integral where p is 1 and of this type. P is 1, this type of integrals are divergent. So this means that the bigger one is also divergent. Yes, so this integral is divergent. Is that clear? Okay, and then the other one, integral from 2 to infinity, d 1 over x ln of x to power 2 dx. So what type of integral is this? Improper integral, type 1, because it is infinity there. But is it also type 2? No, it is not type 2, because I do not have any problems at this limit. Yes, if I put 2 here, nothing strange happens. So this remains bounded. Yes? Okay, so do you have any idea how to do this? Okay, so comparison, if you want to do that, you need to know, compare with what? So this, you know that calculus is a lot of tricks and techniques you need to remember. So this integral is very famous for me. When I see this, immediately I know how to calculate it. And that is exactly at your level. So that is exactly at your level, okay? If you don't see how to calculate this, then you will be in trouble, because I told you that the reason that we don't calculate them, because they usually give us integrals that we cannot calculate. But if we can calculate, it's still the safest thing to do is to calculate. And by the way, they have mentioned that if it is convergent, find the value. Okay, so can you tell me how should I calculate this integral immediately? So you don't listen to me, okay? Whenever you see a function there and its derivative appears here, then it means that that is a substitution method. Yes, ln of x is a function. What is its derivative? It's 1 over x. Okay, so it's not hard. You just need to follow the rules of thumb. Because I would say that this I will tell. First of all, I write the definition, integral from 2 to r, and I send r to infinity. I just finish it. And then I would write x ln of x, and then I will have to power 2 dx. So what I take u to be ln of x, and this means that du is 1 over x dx. And then what I have, I would say that x goes from 2 to r. This means that u goes from ln of 2 to ln of r. And then this integral that I call it ir is ir equals to integral, instead of this, I would write ln of 2 to ln of r, and then I have du divided by u squared. Yes, instead of ln, I put u. Instead of 1x dx, I put du. But this is also famous. It becomes minus 1 over u. I have to calculate it from ln of 2 to ln of r. So this becomes 1 over ln of 2 minus 1 over ln of r. Yes? And then I calculate the limit of ir and send r to infinity. Ln of infinity is infinity, so this vanishes, so this becomes 1 over ln of 2. So this not only tells you it is convergent, but also tells you what the value is. Yes, so it is convergent and convergence to this particular value. Okay, so the next two questions are actually very good questions. So next time I will start with these questions, and I think the rest of it shouldn't be very hard for you. Finding areas and volumes, you have already studied them in high school, so might be I just go through them very fast. But the last part, which is parametrization and finding the arc lengthless, probably you haven't studied that before, so I want to spend most of the time of the next session on those topics. Any questions? No? Okay, thank you very much.